Hey friends, isn't this a lovely day? We're just having all kinds of fun at dotnet Conf, John.
I'm feeling like a friend in Scott's presence. I've seen so many of his videos, so I feel a bit awkward and awesome here right now.
Oh, well, flattery, sir, will get you everywhere with dotnet Conf. I appreciate you as well. I've read your books, and you were recently on my podcast. You're just a joy to work with, so we've teamed up to talk to you today about .NET and about AI and about how I think about it, how you think about it, and see if we kind of think about it together.
Interleaving processes.
Indeed. So I'm going to just bring up my machine right here and explain a couple of things that I've been thinking around .NET. I happen to be at the OpenAI website, and I did it on purpose. I went there rather than Azure because I think that we need to kind of talk about the base part of the pyramid as we build up to these intelligent apps that we're going to see a little bit later from Maria and Luis. Okay?
You want to go to the lumber, basically, the lumber yard.
Yeah, exactly. We're going to build this thing from the basics, and a lot of people are talking about ChatGPT. It's fun to say ChatGPT. It's fun to say AI. You know, it has good mouth feel. And I think that's a problem because it gets a lot of people hyped, but they forget that data science and ML and statistics and math, these are all things that have been around for 40 or 50 years. I feel like people are confused because it feels like AI just happened last year. But there's a lot of interesting stuff going on, a lot of science and a lot of work that's been happening in this space. So maybe demystifying it a little bit. Is that cool?
Let's go.
All right. So I'm in here, and I was just going to go and say, it's a beautiful day. Let's go to the... And I like to dictate my my stuff because I don't like to type too much. It's a beautiful day. Let's go to the. Now, in the corner of my ChatGPT here, I put in full spectrum probabilities. If you just say, hey, AI, tell me what the next word is. In this case, it's a beautiful day. Let's go to the. We don't know what it's going to say. We can actually say, show us the full spectrum of possibilities. And let's turn on some token highlighting. It's going to say which token was the most likely to be generated. So, John, it is a beautiful day. Where would you go?
I would go to Seattle, where it's always sunny.
It is always sunny in Seattle. It's always sunny in Seattle. And I'm from Portland, and maybe I would go somewhere else.
Maybe it's sunny there too.
But that's interesting because you and I have context about each other. You know, I know where you're from, you know where I'm from, and in our relationship, as we learn to finish each other's sandwiches, we know what the next word is because John and I, as we're new friends, are becoming statistical models in each other's heads about what's the next thing that John's going to say.
Our contexts are lining up.
Classic John. I knew you were going to say that, and I appreciate that you said it. You see how that works? I've been married for 25 years. My wife now knows exactly what I'm going to say. It makes me wonder from an identity perspective, am I a good husband or am I just the most likely thing that Hanselman's going to say next?
And if she's an Azure person, as someone who's watched all your videos, I complete the Azure sentence as your spouse in that way.
I appreciate that. So let's see where John and I would go. It's a beautiful day. Let's go to the... interesting. So OpenAI said beach. And we can look at that full spectrum there. It suggested that beach was about 21% likely. Surprisingly, not park. Park is really common. We're effectively playing Family Feud.
But if you're in Hawaii, you might not say park, right?
That's a great point. That's a fantastic point. Let's actually test that theory. So I'm going to go and take that text, and I'm going to make a little space before it, and I'm going to say, we're currently in Hawaii, comma, my wife was born in Hawaii, period, and we just love this state, period. Now, of course, none of this is true, but we're going to test it anyway.
That's called grounding these days?
Yeah, so we are grounding. Look at that. Now, this is interesting. What's the word north doing there? Well, because the North Beach is a known place on the Big Island, right?
Okay,
so maybe that's why. By putting this little bit of context there, we could say this. I'm with my friend John. He's from Seattle, comma. It's a lovely day here, period. We're big fans of the Pacific Northwest, period. Okay, now let's remove the and see if it's going to do something else. Maybe it wants to go to the gum wall in Seattle. Who knows? Oh, that's interesting. Let's go to the beach. Okay. But then they said, and enjoy seafood from Pike Place Market.
You know, my mom is born and raised in Hawaii. Could you add in a little bit more context? Like John's mom is from Hawaii.
Oh, that's a good point.
And loves it there.
John's mom is from Hawaii and she loves it there, period. So this is interesting. Would you call that conflicting context or just more context? We don't know. Oh, look, oh, it's built a whole narrative about how we've been friends since high school.
It knows me.
And look, we both agree that someday we'll make a trip to Hawaii and take John's mom with us.
That's beautiful. She'll love that.
I'm getting verklempt.
Thank you. Thank you, Scott. Thank you, Scott. You all saw it just now. Thank you, Scott.
That's so cool, though, because what it's done is it's brought all of that context together and it's built a whole thing around it. So the question is then, is the AI smart? Is the AI thinking? We don't know, right? We don't really know how these neural nets are working, but they are picking the next likely thing, and they're using all that previous context. But we only gave it 2 sentences of context. You've known your mom your whole life. You could give it a whole book of context and stories from your childhood. That could be context you could feed into the model, couldn't you?
I was never a competitive debate person, but they're really good at that, aren't they?
They're extremely good at that. And adding new extemporaneous speech, adding new context, and the more context you pile on, the more this word is going to be different, right? I'm a little surprised that it didn't say beach, but we could also say something like, I'm in London. And then maybe it sends us to the London Eye, right? Or maybe it sends us to the museum. That context is important to understand because we don't always know. Let's look at this. We don't always know what that context is. It's unseen context.
Interesting. In conventional code, variables are the context.
That's a really great point because we're effectively calling a function, aren't we?
Right.
It's this big world function on the world computer, and we're calling that function. So then all those parameters you pass in.
Absolutely.
Our context. And that's really interesting because, when I started in computers, they said, don't trust user input, right? You have a text box and you put your social security number in it and you make a regular expression to make that correct. We're doing everything that we can to not trust user input. And now fast forward and the entire internet is now just a giant text area and we're not supposed to trust user input. Who knows what they could type in there?
You're using speech Rico as input, but you couldn't do that if you were writing regular code.
That's a great point. Writing my regular code by speech is more difficult, and it would change my context.
Absolutely.
Yeah. So one of the things that we can also do here is we could see what's behind some of that prologue, and not just the context I was providing about your mom, about where we grew up, but also about how I want this thing to behave.
Personality, maybe?
Yeah, that's a great way to put it. I don't like anthropomorphizing these things because it's not a person, but we are clearly interacting with it like it's a person, right?
Tonality?
Yeah, that's a great point. I like that. So in this case here, I'm saying you're a helpful assistant, and I'm expecting it. I'm assuming within helpful is a certain amount of kindness, patience. I would prefer it not be rude. I don't want it to be like I'm calling IT and they're like, Hanselman again? You're so mean. That's
we love IT, mind you.
We love IT. Not endless IT, but the IT of old.
We love IT.
Yeah, we love IT, because otherwise my computer's going to suddenly stop working.
We do the right kind of thing.
Okay, so one of the things that I like to do is I like tacos. I have tacos basically all the time.
Why tacos?
I don't know. Tacos are my jam.
Okay.
Breakfast, lunch, and dinner. And especially when I'm on an expense account and my wife's not here, nobody can stop me from having double meat.
Calzones, tacos, similar?
No, calzones are too much carbs, totally different thing. Not a calzone
I get
guy.
it.
So I could say, I need a taco recipe. So this is pretty straightforward here. We have, I need a taco recipe, and you're a helpful assistant. So I would expect a pretty straightforward taco recipe. Here is a simple and delicious taco recipe for you. Okay. So this is coming from this very large language model that has effectively been trained on the corpus of all the text in the world, right? And one of the things that's interesting, of course, is that the internet is 49% nice and 49% mean, and 2% that are still deciding.
It's guessing really well.
It seems to be guessing, but I have no way of knowing if this is good. I don't know what part of the internet it got this from, if this is the nice part or the not nice part. I don't have a kitchen to test any of this stuff. I could also change this tone over here where it says you're a helpful assistant, and I could say, you're a belligerent assistant, period. You'll eventually help me, but you're not going to be happy about it, and you're going to be sassy while we talk, period.
This could be tragic.
It could be really awful, but we don't really know. But also, I, as the user of the chat assistant, don't know that bit of tonality. That was set up by the user interface people. So then if I say I need a taco recipe from my new belligerent assistant, we'll see something different. We'll see what's going on here. Hello, belligerent assistant. Let's hit refresh.
It's truly being belligerent.
It is being. It's so belligerent. It refused to give me a taco recipe.
There you go.
That is interesting. Let's try it again.
You know that model parameter you have there?
Yeah, this is a great point, actually. By the way, I think this is where...
oh, there he goes.
I was thinking that was where MSIT finally got mad at me. Oh. But yeah, you're pointing out that the model we're using is GPT 3.5 Turbo.
That's a fast one, Turbo, right?
Yeah, it is. Okay, so this is good. Nice. Drain any excess grease, because health, I think. I hope you know how to use the stove. It's being pretty rude. 1 packet of taco seasoning, because clearly you need all the help you can get.
Ooh, wow, that hurts.
It does hurt. If this were the way that it was going to talk to me, then I might not want to spend any time with this model. There was an article a couple of weeks ago where they said, they did some research that if you are kind to a very large language model, it will be kind to you and you will get better results. And I think that's because if you use kindness words, you end up on the kindness part of the internet, the kinder Stack Overflow questions.
Those Midwesterners, right? They get to me.
Have your favorite, kitchen and Iron Chef people? You know how there was a time there in the late '90s, early 2000s where the chef guy was mean, like you're an idiot sandwich, and they were really cruel, and we'd cheer on those mean chefs.
Awkward.
Those mean chefs have become kind and nice now. So I think that I would much rather have a nicer assistant and a kinder assistant. That very large language model, I could then call. I could log into Azure OpenAI Studio, get the REST APIs, and write this myself. But things get really complicated really fast. I want to orchestrate things. I want multiple chatbots to talk to each other. All of these pieces are going to talk to each other in some kind of an orchestration of not just one chef where it's me making tacos, but a sous chef and a prep chef and all of these kinds of things. My kitchen is going to get very messy very quickly.
Well, as your AI co-pilot, literally sitting next to Scott here, I realized, could you go back a couple of frames? Could you go back to the OpenAI interface?
Yes, sir.
Yeah, OpenAI.
Oh, back over here?
Yeah. So like there's that little flipper here where you chose the model.
Okay.
So we know that there's all kind of models. It's like walking into a supermarket. Which model do you use? You chose 3.5 Turbo. 4 is a pretty good model.
That's a great point. I chose 3.5 Turbo on purpose because my thinking was it's 16 times less resource intensive than ChatGPT 4. It may not be as good, but good in this case depends on what my needs were. So my needs were simple. So I wanted to use the smallest model that would get the job done to be respectful of cost and of resources. I don't know if that was the right thing to do, though.
Well, in Japan, they have this weird business where they sell very expensive fruit. Are you aware of this? Like a melon can cost $200, or a peach can cost $150. This is very good fruit.
Okay. Is it $150 good?
Well, that's a question. Sometimes it is. If you're really in that mood for that peach, yes. And so I think of 4 was traditionally that very expensive peach, but as we know from OpenAI Dev Day, that new model is going to get a lot cheaper.
That's a great point, because the quality that is required to bring that to the market will then be understood, it'll be codified, it'll become commoditized, and it's going to go down market.
Right. It's kind of like we got used to like this kind of goodness and this good, relatively inexpensive model, but suddenly each few months we're like, wait, I thought that was expensive and too and good. It's going to be cheap and good, and it happened like within a few months.
Interesting. So that's a great point. I think it is valid to use the one that is the cheapest for your needs, but also don't underestimate that the others are going to become cheap soon.
Remember in the era of like the Pentium 150, Pentium 170, we had to have the latest, right?
Yeah.
And it kept like dropping in price, but it was better, right? Same thing happening here. So weird.
That's a great point. And you can, in fact, buy Pentiums and 486s, even now in 2023, for $3 in a bin, and you can have a pile of Pentiums, and they used to be $1,000.
Yeah, it's coming. And so that model, if you go forward to your slide of the Copilot Stack, I find really useful as a segue to what is Semantic Kernel and why we love AI in the .NET universe via Semantic Kernel. And basically, this toaster here is a kind of metaphor for semantic kernel. You turn up the heat, temperature. You are kind of cooking something. You're orchestrating something there.
Okay, let's go to a two-shot here and let's see what's going on, because John has actually brought a toaster, one of our first
toaster right
folks
here.
to bring the toaster. We'll switch, there we go.
And maybe to get in the mood, if you wouldn't mind putting on a Cozy AI Kitchen apron, would you do mine?
We are actually going to...
We're going to go into cooking mode here. Yeah.
Be cooking.
Yeah, it's cooking mode.
So we are now entering John's Cozy
AI Kitchen. Okay,
AI Kitchen, being respectful of our microphones.
There we go. Okay, so...
Thank you, sir.
All right, here we go. All right, so we're going to do some cooking, and we do the cooking to understand the materials. And I really, this is a fanboy moment, because I really am new to Azure, and I've learned so much through Scott's videos. And what I realize every time, as a teacher myself, you have to understand where the materials came from, or you cannot understand what this is. I once worked with a curator in Kyoto who told me this life-changing story. And he told me how he once was able to interview one of the last Mia Daiku. They're Mia-era carpenters. Oh, wow. They're ordained by the emperor as like special carpenters that can build temples. And these temples in old Japan stand for not just 20 years or 100 years. They stand for thousands of years. So this carpenter was asked, how do you create these temples? How do they last so long? Because modern architecture lasts for like 30 to 40 years. And so he asked, of course, in a Yoda fashion, well, why do you think they stand for so long? And the guy said, must be the architecture. And the carpenter laughed at him hilariously. He said, no, it's actually very simple. We, the Mia carpenters, go to the mountain, we'll pick trees from the east side of the mountain and bring them back to the site and use them only on the east side of the site. Then we go back to the mountain, to the north side of the mountain, take trees to the north side, and use them only for the north side of the site. And so basically all the trees are picked in a way that it fits nature's capability, and that's why it stands for so long.
There's an intentionality, there's a deliberateness, there's a focus. It's not just being slapped together, it's being done with a plan.
The raw materials change everything. It's kind of like why I noticed how you wanted people to start from the beginning, go to the lumber yard, because then you can understand it. So in that sense, that's why in the Cozy AI Kitchen, this is GPT-4, the model that was expensive, now a little bit cheaper.
That is heavy. That is foundational.
Foundational, exactly. It is a foundational model. And what we do, as you know, you were using tokens.
Yeah, so that's a great point.
Yeah.
I didn't get too into that, but each one of those words gets broken down into a token. So in this case here, we have tokens in the form of die or dice.
Dice rice, right?
Dice rice.
There we go. Yeah, exactly.
There we go.
No
I'm
problem.
dropping rice all over the place.
Yeah, so because they're random, right?
They are totally random. You're absolutely right. And we would then pick the one was the next token. I feed it tokens and I get more tokens out.
Yeah. So we need tokens. We need orchestrator. We need our model, foundation model. And so let's grab some semantic code, shall we? And put some tokens in the orchestrator.
Okay.
Do you mind pouring some in there?
So we have semantic
there we go.
code here.
Pour them in here. Yeah. Okay, there we go. Yeah. Okay, there we go. We're not paying for this. Okay, good, perfect. Yeah. Okay, so we have some tokens in there. So that's semantic code.
Okay.
But as a longtime coder yourself, we didn't have this fancy semantic code. We had good old-fashioned code, right? Old-fashioned code, right? So the key to these systems is you want to mix semantic code with native code. The two go together, right? So if you can add some conventional code in there.
Okay.
So we got two kinds of code.
That's a good point, because I might have an existing website, with existing code, old-fashioned code I could have wrote yesterday.
Right. Old-fashioned code's good. It's like
it's nutritious.
It smells good, right? Okay. So we got some old-fashioned code. Okay. So that's like the foundation of how to do that. Fill in the right, the generative model, the completion model, and that is ungrounded. So we want to ground it. What are we going to do? Well, we don't use this GPT-4 model. We use a so-called embedding model, like Ada.
So Ada, that is, that's interesting, because I felt a moment ago maybe you were upselling me.
Okay, yeah.
And saying use the biggest, fanciest one.
No, yeah.
But Ada is a smaller model, and if we switch out to my slides just very, very briefly, you can see some of the models in the GPT family of models. Ada, of course, is a nice one for formatting text, for parsing. Very inexpensive. It's nothing. It's fractions of pennies.
Yeah.
But it's a solid foundational model.
It's a solid foundation model for embeddings. And with your slide up, for those of you who have heard these names before, A, B, C, D. Ada, Babbage, Curie, Da Vinci. Ada, oldest. Da Vinci, newest. I had a moment when that happened for me.
Interesting.
Also alternating gender, too. It's pretty cool.
It's also interesting to point out, if you think about these in terms of the planets, Da Vinci being the Jupiter of the thing, and Ada, of course, being like Earth or something like that, this is not to scale. It's fair to say. 175 billion parameters, Da Vinci would be so large that Ada would become a pixel. So you got to understand how large these things are. The difference between 175 billion parameters and 2.7 billion doesn't fit on the slides.
And when you look at that thing, you think, Ada's so puny.
Yeah, you're like, well, it must not be good. What is it good for?
But we love it for embeddings. And what embeddings are, it is we use it for embeddings, particularly to be able to take words and convert them to long vectors of numbers. If you want to read what it says here.
We've got here long grain embeddings, vectors like your grandma used to make. These are very comforting.
Grandma.
These are vectors from our vector. This is almost a database of vectors.
We're adding grounding. If we can add some grounding into the semantic kernel. Excellent. Okay, so now this combination of embeddings and the completion models enables a grounded semantic computation.
Right, and by grounded you mean it's not going to make stuff up, it's not going to get confused, it's going to get more focused on what we want it to do.
It is going to be less likely to be less grounded in how it communicates. It's going to be biased, the way you bias the system.
That is a really great point, because we talk about bias as it's a negative thing, but if I'm making a coffee shop chatbot, I hope it is biased towards my coffee shop and towards selling the products that I have, and it doesn't start making limericks about coffee.
It's also called steering, right? You steer it, right? Okay. So
that's a great point.
So that is a simple way of explaining how the two models interact, and you get basically this magical interleaving of context and completion together.
This model, GPT-4, does not run on my laptop. It's huge. It runs in the cloud. It runs on GPUs.
It's big, yeah.
Where is Ada located? Is it another website?
Ada is also up there too, but as more people discover, you can run embedding models locally. And of course, we know you can run these kind of models locally as well.
Interesting.
Smaller ones.
So when we say running on the edge, depending on the size of your company, the size of your project, the edge might be your laptop in the case of a smaller model, or it could be a machine that's in your local data center if you have a hybrid cloud.
Yeah, if I had like a water jet cutter, I would cut this into little tiny model, a tinier embedding model, a tinier foundation model for completion. Absolutely. So now, I wanted to, because your audience is expecting something, they're
expecting
.NET.
They're
expecting .NET. Well, I want to show you something new that we've created in Semantic Kernel to take it up a level to what OpenAI Dev Day announced something called Assistants.
Okay.
And Assistants are an abstraction on top of these components that makes it easier to write this kind of AI.
So but let me just ask a quick kind of grounding question for myself.
Excellent.
I saw on my little demo where I can, log into OpenAI, I can log into Azure OpenAI, I can get a key, and I can make, basically API calls very manually. I could get down to the HTTP of it all, correct? And call into those models. I send it a string and I get back a string. But I'm gonna outgrow that very quickly if I'm trying to build an intelligent app. Is that a fair statement?
Well, the thing is, you're not going to outgrow it. You're going to be swimming as fast as you can. They say the duck doesn't look like it's actually paddling underneath the water. That's you and AI right now. I got it, boss. But you're swimming so fast, and you're like, oh my gosh, it's hard. So this assistant abstraction makes it a lot easier to work with this kind of AI. The problem, however, we talked about grounding and humanization. It is a more humanized metaphor, so just caution. What I'm going to show you is not trying to humanize the model. It's an attempt to bring back an idea from the 90s called agents.
I remember agent. I remember the little paperclip was a Clippy was an
Thank you. Yes.
The little wizard, Microsoft Bob.
Bob, thank you. Exactly. Bob was
that.
the first deployed agent. And so what we're going to do is we're going to bring in something called, well, we're going to do two things. The first thing is plugins. The semantic kernel short is plugins, planners, personas. Plugins are the foundations of enabling this AI to go and do things outside of its world. If you look at your Copilot Stack, diagram, at the very top is plugins. And plugins essentially extend the capability of the AI. And so what we want to do is we want to add a few, maybe we can add a few plugins. Let's add in like a Bing plugin.
Yeah. So while we're doing that, bring up my computer real quick. So let's just remind ourselves of where we are here. That orchestrator, to try to have these copilots talk to each other, these agents, require plugin extensibility. Because when I said, hey, John's from Seattle, Scott's from Portland, it didn't go in Bing for that.
Nope.
That was all based on what it found in the foundational model. But I'd like it to, grow arms and do stuff and go out and search the web for things. And it's plugins that makes that happen.
You want to give it a tool belt.
Ooh, I like that.
Right.
Or an apron.
Yeah, or an apron, exactly. It's protection.
Okay.
So we've now given it the ability to access tools on its tool belt. And then what we're going to do is we're going to use this new abstraction, personas, also called agents, also called assistants now. This is my jumbo jar of personas. And let's open it up. Yeah, good. Okay. So let's put a few personas in there.
I think this is where it gets a little weird.
Yeah, I have a fascination for wooden dolls. I can't help it.
Like,
yes.
It's made of people.
Yes, they're automatons. Let's call them automatons.
Okay, they're automatons.
There you go. Let's get computer science.
A little Soylent Green there.
That's good, guys. So those are essentially personas, definitions of this abstraction called assistants.
I see.
And then we're going to give it some steering. We're going to define what a researcher is. We're going to define what a project manager is. Okay. Now, if we can switch to my screen now.
Okay.
We're going to show how assistants work in Semantic Kernel with the assistant kernel.
Okay. So we're thinking about these personas as we switch over to John's computer, which is the dark mode machine right there.
Right over here. Okay.
You've got some definitions under assistants.
Yeah. So under these assistants, we have the ability to define a designer, the image designer, who you are, your designer creates images. This is a job description for the agent.
Well, this is interesting because I was over there saying you're belligerent and you're helpful.
Right.
You've taken that out, and that is now the definition, this agent.yaml. You've described how I want you to act.
Absolutely, yes. And what models can it use? It uses GPT-4. And what kind of inputs does it like? Does it take? A project manager. You're a project manager. You enable to the user to finish things. And you notice how there's 4 of these. You put some personas in there, some multiple ones. It's with the intent of enabling the agents to collaborate with each other to produce an outcome.
Interesting. Okay. This is like, now if we go back to the kitchen metaphor, because we've got our lovely aprons here. You've got your sous chef, you've got your prep chef. This is about separation of concerns. You've got roles. These personas are being explicit. And I love that each one can use the correct model that is appropriate for their job.
Well, I like how you described it as AI microservices, basically.
It is AI microservices, which is an analogy that makes sense to me as a .NET developer.
So let me show you this running. So I have spun up the agent conversation space.
Okay.
I want to make a house that is the
So you just said .NET run.
I did. I'm getting used to that command. I love it. It works. A house that is the size of the tallest building in Paris.
So you're asking a lot of it here. You want to make a house, which is a whole thing, but then you also want it compared to the tallest building in Paris. So you need to know that information, which may or may not be current. I don't know where that information is.
And now the researcher, the project manager, has baton passed to the researcher to go and figure out the tallest building. And it's basically contacted Bing. Bing is in its tool belt. And it went off and it gave the information. It gave it back to the project manager. And then the project manager constructed the ability to create the house at the right size.
So you asked the project manager agent, which was described with a specific prologue, with a specific model, to do something. How did it know it couldn't do that and then needed help? How does the project manager know to call on a researcher?
That's an example of scoping the AI microservice, essentially. This is what you're good at, so it stays on point. And therefore, if it doesn't know it, and your job is to hand off, pick the agent that you know about to hand it off to. It's an example of where the general AI approach is to be able to be good at everything. But as you know, when you narrow its scope and focus, it gets really good at one thing, like picking a beach according to your context.
I really like that because when I interview someone, I like it when they say that they don't know. Because that means that they know what they know and they know what they don't know and they're willing to say that. I would rather it be grounded and say, I don't know, let me ask and I'll get back to you.
And the coolest thing is you can tell some agents have access to certain plugins. Like the researcher agent has access to the Bing plugin, but everyone else doesn't. So you can sort of manage security as well.
That's a great point, because there is those multiple personas, each one having individual access to some third party. I might have them running under different security contexts.
Absolutely.
And it might not just be Bing. It could be a plugin that's looking at internal documents, and I don't want another larger model to see those internal documents. Totally in control, but orchestrated by the semantic kernel.
Exactly. So this assisted kernel is a new concept we released for .NET developers to play with, and we're looking for opinions out there.
Okay. So folks should try out semantic kernel, and we're going to see more semantic kernel when Luis and Maria come around, because they're going to get even deeper into this, because there's so many ways to tie these things together. Now semantic kernel does it in .NET, but other languages as well, correct?
Absolutely. Python and Java.
Mm-hmm. If we switch back over to my screen here, I just want to call out this stack again. The AI infrastructure at the bottom, that's your GPUs, that's the cloud. Then you've got your foundational models, like we saw with our heavy ingredients here in the form of Ada and ChatGPT 4. Then there's the user's perspective, which is, wow, I'm talking to a Copilot, that's amazing. And it went and it binged for stuff, that's cool. That orchestrator in the middle, that's the thing. The orchestrator, that is the role of, in this case, semantic kernel. And semantic kernel is that center of that Copilot stack.
Yeah, and it's the brainchild of Deputy CTO Sam Scalace, who also in his history invented something called Google Docs. And he had access to GPT-4 last year ahead of everyone else. And I think he might have consumed the most GPT-4 tokens like popcorn.
Oh, yeah.
And he noticed it was good at reasoning. So that's why the semantic kernel was designed plug-in first to have tools, planners that can access it, so do multi-step. And the personas have been, we didn't expect it to happen like so soon, but after Dev Day for OpenAI, it's here.
And I really like that you said grounding multiple times. You're focused on making sure that this is doing the job that it needs to do and not trying to step into places that it's maybe not good at.
Well, I'm so proud to be at Microsoft because that Copilot Stack, another diagram that I'd like to show is that we built AI safety into each layer because as engineers, you know it's impossible to make something completely safe, but you can architect it to be safe. So AI safety is in each layer.
That's a great point. And also that you made that comment about the Japanese carpenters being intentional and being deliberate about what they're doing. You don't want these things to run off and cause any kind of trouble because you're just making a coffee shop or you're making a kitchen. You really want them to do the right thing. Now, I know that we're going to have some questions. Our friends who are running on the tags board may have questions coming in at .NET Conf. If you want to ask questions of us, because we're live right now, you can do that at #.NETConf. We've got John here and myself to answer questions for you, so feel free to throw those questions at us, and then our friends over on the big board will jump in and ask those questions to us. We'll get the questions answered as much as possible. You know, I was able to get the semantic kernel working very, very quickly. Sometimes with these kind of demos and things, you're like, this is going to take me a while to set up. I was able to get the Hello World example running within just a few minutes, and it was a lot easier. As a .NET developer, I just brought in the NuGet package that I wanted. And in this case here, like if you bring up my machine, it was quite easy. Let's go ahead and switch over to my computer very briefly as we wait for some friends to give us our Q&A.
That's music to our ears, and also this is a community project, so for those of you who want to contribute and improve it, or even provide constructive criticism, please send it our way.
Yeah, so let's switch, go ahead and switch to my computer, please. And we can see here on line 1 that I've got using Microsoft.Semantic Kernel. Just a NuGet package, bring it in. We're going to build up that kernel. I have my Azure OpenAI key hidden there inside of my region. You can see between lines 9 and 12.
Oh, that's how you do that. That's so cool.
So what I did is I just made a region, and you see I collapsed that region.
Oh my gosh, another Hansel moment.
Wow, look at that. Got nothing else out of this talk except that was the thing. Hide your stuff in regions. Appreciate that. So yeah, just say, hey, I want to use the OpenAI completion service. And then to your point, ask for that. Semantic kernel, this is just probably 7 lines of code, with a bunch of white space. And then I could go and say summarize.
It's meant to be simple, made for the AI app developer, not the machine learning engineer. It's meant to make because a .NET developer is busy with their real work, and Boss said go do AI. So we want to make it easiest for them to help make Boss a little bit happier.
You said something funny earlier when we were talking about why this was a good idea, and you said, I think that a lot of .NET developers maybe don't know what's going on around AI. And I said, why do you think that? And he says, because they're working. They're getting stuff done. Right. They're taking care of business, and I think that's really great. Let's see if we have any questions. I haven't heard anyone from the tag board pop in quite yet. I'm waiting for that to happen. In about 5 minutes, we're going to go into Maria and Luis, who are going to go deep into how to do these, creating bots and in different things with .NET and Semantic Kernel, because these are now not just apps, they're intelligent apps. Right? These are apps that are smart.